going to do a small course on the influence line. I would like to start with an introduction, and I will divide this introduction into 3 parts. We will use the analytical method to determine the influence line of support reactions and sectional forces for the following basic beams. In this section, the first part, we will make the simplest beam supported on a fixed and a movable support. In the second part, we will do a cantilever beam, and in the third part, we will work with a vertical blade and a support. These will be the 3 basic beams that we will rely on in the further course, to which we will return, and use especially for sectional forces. A unit force moves across this beam. It can be from the left side or the right side. We mark this force along the length x. I made a cut at a distance from the left support, meaning the total length of the beam is L. Here I've divided it into A and B. Generally, our goal is to consider what part of this force will be resisted by this support, depending on where the force is placed. This force moves, and we are to show on a graph how the reaction at the first support behaves and how the reaction at the second support behaves. So we know that there are reactions here, let's say VA and VB. Now let's consider that when the force is over this support, the entire force is taken by reaction VA. And when the force is over support B, the reaction VA is 0. And the influence line will generally always be a linear function. So having these 2 pieces of information, we can actually draw the influence lines. And similarly, contemplating how reaction VB takes this force. When the force is at the beginning, since VA takes everything, VB is 0, and when the force is over support B, B takes everything, so VB is 1. And we connect this function. So this looks like that. This can be inferred in layman's terms, and now we will do it using the analytical method, which means we will write the equations. So the sum of moments at point A equals 0, we write the static equations normally. So it will be 1 on arm x, I assume right-hand moments are positive, minus VB on arm L equals 0. From this we derive VB equals x over L. And we double-check for coordinate 0 and coordinate L. We plug in 0 for x, so VB equals 0, it's correct. If we plug in L, L over L is 1. And for the sum of projections on the y-axis, we calculate reaction VA, simply VA minus 1 plus VB equals 0. From this we derive VA equals 1 minus x over L. Here I substituted VB. Now we replace 1 with L over L. We have a common denominator, L minus x over L. And we verify at the beginning and end of the interval, which means for coordinate 0 and coordinate L. If we substitute 0 for x, we get L by L, which is 1. And if we substitute L, we get 0 by L, which is 0. And these are the influence lines for the support reactions. And now we will create the influence lines for the cross-sectional forces in cross-section K. First, we'll create the influence line for the shear force in cross-section K, which is like making an imaginary cut at point K. Whether we look from the right or left side, the shear force will be the same, but we'll always do it in a way that is easier for us. The example here is very simple, so there's not much room to simplify it further. It's already easy. But you must know that we can make this influence line for the shear force either by making an imaginary cut and looking from the left side of the section, or cutting off this left part and looking from the right side. We can do this because generally we need to consider 2 situations. First situation, the unit force that travels is either before the section or after the section. We can set it up so that the first interval is when the force is before the section, meaning x is from 0 to A. Then we can look from the right side where there is no force. Let's say the force goes beyond the section. And we make the second cut from the left side. It's like avoiding the force, but like I said, there won't be much difference since the example is easy. In the first interval, the force is before the section from 0 to A, so this is literally how it looks. The shear force in section K from the left side is Va1. I'm not avoiding the force here because, as I said, it's such a simple example that there's no need. I've calculated VA before. It's Lx by L. Subtracting 1L over L gives me minus x over L. I check the start and end of the interval. For coordinate 0, it's 0. For coordinate A, it's minus AI over L. Now for the second interval, the force is beyond the section, from coordinate A to L. It looks like this, symbolically, because it's a variable. I continue to look from the left side, so I no longer see the force. This will be Va, with only the reaction Va remaining. I make the cut so I don't see the force, only from the left side. Here I have va itself, which is positive because it's upward. In the first cut, I also saw the one going down because the force was before the section. Okay, we'll erase this. Now let's check for coordinate A and coordinate L. If we substitute A, we have L minus A by L. L is a plus B. So IEA is cancelled out, leaving B over L. And if I substitute L, I get 0. So the graph, I don't know if I'm drawing the graph here. No, first I'll calculate the bending moment. It is now the line of influence of the bending moment in cross-section K. So the same situation, I can make the moment from the right or the left side. And let's see, the first interval of force before the cross-section, I am doing it from the right side now, so now we will avoid the force. From the right side, well, I'll do that. Yes, I don't see what is here, meaning this force is before the cross-section when viewed from the left side. From the right side, I have simply positive VB, because you have already taken the resistance course, and remember that this is the positive direction when viewed from the right side. On arm B, which gives us x over L I took from the reaction VB, that's what I got, times B. I substitute the coordinate 0 and coordinate for the coordinate 0 we have 0, and for coordinate A we have a times B over L. And now the second interval force is after the cross-section, and I will now do it from the left side, which means I cut what is on the right and look from the left. From the left, all I have is VA. It is counterclockwise, meaning positive from the left side, looking on arm A. So VA times A, val minus x over L times A. I check for coordinate A and for coordinate L. If I substitute A, then again L is a plus B. Here A is shortened, B over L times A remains, which is a times B through L, which is what was here earlier. And for the coordinate L, it zeroes out. And now I can draw the influence line, which is the influence line K. And here we have a over L negative at the bottom. Where was it? Here, and at this point, there will always be a jump by 1 on the shear force influence lines in any given section. Here we have a jump from minus A over L to B over L. And the influence line of the moment looks like this. From 0 to a times B over L and from a times B over L to 0. That's it. I will try to make these videos shorter, so they are easier for you to watch. And now I invite you to the second part. If anything here was unclear, hopefully not, but if so, I encourage you to ask questions under the video. Remember to like us, visit, and subscribe. Bye!